Okay, gents, I'm in my year 10 lessons with my 10.4 who are moaning about this particular task here, programmable timer. Can you make a timer where you control how many minutes it's on for? So can you make a timer where it's not just on for 10 seconds, for example, or 10 minutes? You can actually, with an input, you can control whether it's on for 10 minutes, 20 minutes, 30 minutes, or 1 minute, 2 minutes, 3 minutes, 4 minutes, whatever that thing may be. Can we write a program that can do that? Well, let's have a look. This is my circuit, so let's go straight to my flowchart. This is a silly little program I wrote before. So let's start off on what we're going to do. Well, I'm going to use, if we go back to the PCB layout, I'm going to use this button here. So that would be D0 as a reset. I'm going to use this button here, which would be D1, as an increase my minutes by 1. So you can put it on for 1 minute, 2 minute, 3 minute, 4 minute, whatever. And I think I'm going to make a 5-minute timer. And I'm going to have this button here as my go button. So it starts a countdown. That's what I'm going to do. So we've got reset, we've got like a programmable button, and we've got a go button on D0, D1, and D2. So back to the flowchart, start and start. I'm going to have 2 different programs here. There's a reset button. So, oh, sorry about that. I'm going to pull in a digital. And this is going to be D1. Is D1 on? Yes. I'm going to call that timer. Okay. There we go, and I'm going to double click on here and I'm going to call this the reset. So I've got 2 different flowcharts there. That's important if I want to reset a specific flowchart, but to be honest with this, I think I'm going to reset all of the flowcharts if D1 is pressed, which I think is wrong, isn't it? Isn't it D0? I think that's right. Ollie, you off? See you later. So if D0 is pressed, just go back and up. If D0 is pressed, then we're going to reset. Okay. Next up, then, what we're looking to do is create a variable, and every time you press that, we increase that variable by 1. So back to the flowchart. I'm going to declare a variable first of all, which I think you need something called an expression. I think that's the one we need, which I can never find. It's in the maths bit of it. There we go, expression. And we're going to have the variable x, and it's going to equal, no we're not, we're going to use t actually, t for time. T, and that's going to equal 0. Okay, so t equals 0. There we go. So when we kick off, t equals 0. Happy days. Now we're going to ask the question, has D1 been pressed? Because if D1 has been pressed, then what we're going to do is increase t by 1. So let's ask that question, really easy thing to do. Has D1 gone on? If it has gone on, great. If it hasn't gone on, we're going to just go around. We don't want to go around here because then we'll be influencing that variable. We just want to be going around in a loop. So has it been pressed? And then we can go down to this little increment to I and C, which is with the expression. I'm leaving a bit of space between these different functions because I'm not doing this properly. I haven't really considered this, and so I imagine I'm going to put different bits and pieces in, so I'm leaving a bit of space in between each one. So what am I going to increase by 1 every time? I'm going to increase t. So t is going to be increased by 1 every time that is pressed. All right. Right. So I think what I'm going to do next is move this over here. Nice little thing I showed you on the last one. Display page. So just get rid of that funny little external bit. Okay, so I think I'm going to take that away. And I'm going to ask the question, has D2 been pressed? Because if D2 has been pressed, then we can start the countdown. Yeah, that's right. Okay, has D2 been pressed? So we're going to link that up with if D2 has been pressed. If D2 has been pressed, then I'm going to declare the expression that C equals T. That's what I'm going to do. I'm just going to try and find that expression. Right, okay, there we go. So, I'm going to say that C equals T. What I'm going to do is, because that is a single digit and I want to turn it into minutes, I could, if I want to turn it into minutes, what I could do is I could times it by 60. I tell you what, I'm not going to do that just because it'll take so long to show you if it works or not. So I'm going to leave it there. Well, I could have times that by 60. So then whatever C is, T is 60 times more, converting seconds into effectively minutes. Okay, see, right. Once we've done that, we are going to put a wait command in. Here of 1 second. And then we're going to decrease C by 1. So if C did equal 3, we're going to wait 1 second and then C equals 2. Okay, and then we're going to wait 1 second, then C equals 1. And we're going to wait 1 second, and C equals 0. That's what we want to do. And then if C equals 0, what we want to do is we want the lights to come on. So let's have a think about that. How are we going to get the lights to come on? Well, we're going to ask. We're going to compare. I'm going to put a compare function in. Does C equal 0? Well, I've got to watch it here because if T equals 0, then light's going to come on. I think up here, what we're going to have to do is put a C equals something like 100. So I'm going to copy that, and the reason for that, you can see if C equals 0 down, if C equals 0, we're going to suggest that C equals 0, therefore turn all the lights on. Well, C equals T, and if T equals 0, then all the lights are going to come on at the beginning. I hope you follow that. Okay, C equals, I think this is going to work. Let's type in 100, okay? Doesn't really matter. Or we could go for a minus figure, couldn't we? Let's go for a minus 100. Oh no, it's not working. Okay, so let's go for 100. Okay, just to stop those lights coming on right at the beginning. Right, so C equals T, wait for 1 second, decrease C, so from 3 goes to 2. Does C equal 0? C equals 0. If C does equal 0, then we're going to turn all of the outputs on. So let's go to the outputs. Here we go. Let's turn them all on. Nice one. Here we go. Looping back round, increase T by 1. We're going to loop that back round as well. So I think that's around about high. They're going to go on, and we want them to stay on for, let's say, 3 seconds. So I think we can put a 3-second command in there. Put time in there of 3 seconds. Oh, 3 seconds. Okay. And then after that, what we're going to do is we're going to turn all outputs off. and then we're going to come back around to the beginning again. And we're going to start all over again. Just going to follow this. Now, that's my first stab at this program. Let's just see if I connect
You hatched already?
Right, what happens if it doesn't equal 0? If it doesn't equal 0, then we're going to go back round to wait for 1 second and decreasing c by 1. So for example, if c equals 2, then it doesn't equal 0, so we don't go on. If we go back round and we're going to wait another second, then c equals 1, then we're going to go back round, then c equals 0, does equal 0, everything comes on, and we know that the timer has finished. I think that's about right. Of course, what we could do with this is we could start putting outputs to show how many minutes you've pressed the button for. That would go in somewhere like here. Once we define what C is, if C equals 1, 1 output could come on. If C equals 2, 2 outputs could come on. If C equals 5, 5 outputs could come on. Or indeed, what we could do is we could flash or pulse a LED the number of times that C equals, and that would be a function which would go in here. So it would go in there and above where that loops back around. Right, let's see if it works now. It seems to be working okay. What we can do with this is have a look at the variables. Now, if I press D1, it's all a bit sluggish, this. Right, I've got this around the wrong way. I'm looking at this variable over here and it's going crazy. And the reason for that is my yes should be going down and my no should be going across. So let's stop that and let's swap yes and no. Okay, done. And then let's play it again. That's better. I should have really made sure it's working properly first. Okay, that's working okay. My variable over here, C equals 100. My T equals 0, which is right. Let's press this. T equals 1. Press it again. T equals 2. Of course, this would happen so much faster. T equals 3. Okay, now I'm going to press D2. Okay, so what's going to happen to T? Actually it's C, isn't it? Because we said C equals T. 0. High all of them. And Loki 5. So let's pop over to the PCB. And we've got the reset there, increased by 1, and then we've got the go. So what I'm going to do is I'm going to play. I can get my variables up here so I can still see. I'm going to press that once. See my T is going up on the right hand side. C presently is 100. Okay, I'm then going to start the program by pressing this one. C should go to 4, 3, 2, 1, and hopefully LEDs come on. Yay, stay on for 3 seconds, and then turn off. Don't really want to turn off, do they? Oh yes, they do. There we go, guys. So that is how you make a variable timer. That is the most basic of variable timers. We could have shown, as I said, how much C equaled by a pulse at some point. And you could do a whole variety of things, but that's the most simple way you can do it. Okay, hope you enjoyed it.